And what will be the vector representation for R21 bar? R21 bar. You want to find out this vector. The equation of the vector line joining the equation of the vector starting from one point to the other point can be found out as the final point minus the initial point. So it is the vector starts from x2 y2 z2 and ends at x1 y1 z1, right? So the initial point is x2 y2 z2 and the final point is x1 y1 z1. So R21 bar would be equal to x1 minus x2 to x cap plus y1 minus y2 into y cap plus z1 minus z2 into z cap. This will be the equation of the vector. So an R12 bar would be equal to minus of R21 bar. Okay. Let's erase the board. Now we know the vector form, the force, electric force, can be mathematically found out as F bar is equal to 1 by 4 pi epsilon Q1 Q2 by R square R cap. This is the Coulomb's law. Now you see the force depends on several parameters in this equation. Force depends on the charges, whether it is attractive force or repulsive force. Force also depends on the distance between the charges, and importantly you can notice that force depends on epsilon, right? So force also depends on the permittivity of the medium. So when the permittivity of the medium changes, then electric force changes, right? Let us see one more or similar kind of force, but that is quite significant when you are trying to understand the effect of electric charge in a field, and that field is referred to as electric field, and we will try to understand what is electric field intensity at a point P due to a charge Q. Electric field intensity denoted by E bar. So let us consider a charge Q, electric charge Q, whose position is fixed. We know in the vicinity of this charge there is some field present. Now we are interested to find out the intensity of the field at various points in the vicinity of this charge. Say there is a point P which is a distance of r from this charge Q. So how do you define electric field intensity at this point P, or how will you calculate electric field intensity? So when you are asked to find out electric field intensity at a point P due to a charge Q which is a distance of r from the charge, put a unit positive charge at this point P and then find the force of attraction or repulsion between the two charges. Electric field intensity is not different from the force that we discussed earlier. It is exactly the same as the force that we discussed earlier, with the only difference that the other charge is a unit positive charge, and here we try to understand the effect of this charge produced at the point P, which is a distance of r from the charge, which is the spatial distance of r from the charge. Okay, so put a unit positive charge and then find the force of attraction or repulsion between these two charges. So we can define electric field intensity as the force experienced by unit positive charge placed at that point P. Right? So if you put a unit positive at that point P, then the force experienced by unit positive charge at that point P is nothing but the electric field intensity at that point P. But as I told you earlier, when we usually talk about force, even though we know it's a vector quantity, but you need to explicitly talk about the direction of the force. And what will be the direction of the force here, or what will be the direction of electric field intensity? The direction would be along the line joining these two charges. So electric field intensity at a point P due to a charge Q, which is at a distance of r from the charge, is defined as the force experienced by a unit positive charge placed at that point P and in the direction along the line joining these two charges. It is the definition of electric field intensity. Now, instead of placing a unit positive at this point P, let us put a small test charge delta Q at this point P, a test positive charge at this point P. Then what will be the force of repulsion between these two charges, the Q and delta Q? So the force between these two charges can be calculated using Coulomb's law as 1 by 4 pi epsilon Q delta Q by R square R cap. Take delta Q to the other side, then you get F by delta Q as 1 by 4 pi epsilon Q by R square R cap. Now I say replace delta Q with a unit positive charge. That means instead of delta Q you put a unit positive charge. The moment you put a unit positive charge, what is this force referred to as? This force is referred to as electric field intensity, denoted by E bar. Denoted by E bar. So electric field intensity can also be defined as force per unit charge at that point P, and it is a vector quantity. Electric field intensity is not a scalar quantity, it is a vector quantity. Mathematically, electric field intensity can be found out as 1 by 4 pi epsilon Q by R square R cap. This is the equation for finding out electric field intensity at a point P due to a charge Q, which is a distance of R from the charge. Now if you observe electric field intensity equation, E bar is equal to 1 by 4 pi epsilon Q by R square R cap, you will notice that A bar is similar to F bar equation, and I told you that electric field intensity is not different from force. It is a kind of force. The only difference is that the other charge is a unit positive charge. Electric field intensity also depends on the charge Q. It depends on R, that's the distance of the point P from the charge, and it also depends on the permittivity of the medium. That means electric field intensity strongly depends on the medium. Even though you fix Q and R, if you change the medium, say from air to paraffin, or from paraffin to wax, or from air to Teflon, so if you keep changing the medium, and even if the charge and the distance remains constant, electric field intensity will change because it depends on the medium. That means you can't consider electric field intensity as a generic parameter whose value can be calculated in any medium. So we are now interested in knowing one parameter whose value can be calculated in any region. And what is that parameter that I am referring to? I am actually referring to the parameter D bar. And what is D bar? D bar is referred to as displacement density, or sometimes referred to as electric flux density. Displacement density or electric flux density. And what is the relation between D bar and E bar? D bar is equal to epsilon into E bar. Very important equation. One of the constitutive relations. D bar is equal to epsilon into E bar. So when you multiply epsilon with E bar, you see the dependency of medium is gone. So D bar can be calculated in any region, independent of the medium. But I told you the reason why we go for D bar is we are looking at one parameter whose value can be calculated at any point in the field, or in any field, right? Why should you multiply by only epsilon? Why can't you multiply by epsilon by 2 or epsilon by 3? Right? So it is not that trivial. This is experimentally proven by the great scientist Faraday. based on his experiments, he concluded the relation between d bar and E bar as d bar is equal to epsilon into E bar, and he named this d bar as displacement density. Later, Gauss verified again this equation d is equal to epsilon E, and he renamed this displacement density as electric flux density. So it's up to us to either call this d bar as displacement density or electric flux density. Both of them mean the same. I'll give you the gist of the experiment conducted by Faraday and how he could relate d bar and E bar, or how he could give the relation between d bar and E bar as d is equal to epsilon E. So the experiment goes something